I'm Dr. Shefali Mishra, Associate Professor, Department of Psychology, Jesus and Mary College, University of Delhi. Today I will be presenting to you a research topic on paradigms of research and exploring the philosophical basis of science along with it. The present lecture will introduce the main research paradigms for psychology while delving into the philosophical basis of science. We will examine the competing approaches to social research based on philosophical assumptions about the purpose of science and the nature of social reality. Overall, the lecture will assist in examining and analyzing the paradigmatic affiliations and associations of research in psychology in a comprehensive and focused manner. We all know that research is essential. Every psychology qualification includes learning about conducting psychological research. Conducting research is quite distinct from simply studying a phenomenon. Research methodology is therefore crucial for ensuring the scientific nature of social science. Then a question comes before us, where is the science in social sciences? Social sciences have been grappling with this question for a long time. Since we have already said that research helps us in scientifically exploring a phenomenon or an event, we must first understand what is the meaning of science in social sciences. After centuries of debate, the question still lingers in our minds. There is no simple answer to this. Having multiple answers to a question, however, does not imply that all answers are acceptable. It means that social researchers select from various approaches to science. There are three such approaches based on a major re-evaluation of social sciences that began in 1960s. These approaches offer alternative assumptions about social science research. These three approaches are: number one, positivist social science; number two, interpretive social science; and number three, critical social science. Each approach is associated with different traditions in social theory and diverse research techniques. These approaches are similar to a research tradition or a scientific paradigm. So the approaches or paradigms are the mental models or frames and beliefs based on philosophical assumptions about what is science. Understanding is about paradigms, that is mental models or framework that we adopt to conduct research, cannot be approached without examining the changing conceptions of the philosophy of science underlying each of the above mentioned approaches or paradigms. Psychology's transition to an independent subject occurred mainly in the 19th and early 20th centuries. This new field of psychology had its own unique subject matter and research methods which were separate from the traditional subjects like philosophy. This development was due to the classic theorists who made an important contribution to the modern world by claiming that the social world could be studied scientifically using similar method as done to study natural world. So, rigorous systematic observations of the social world combined with careful logical reasoning were suggested as a way to gain a major understanding of human relations. After the concept of the science of the social world was accepted, the focus shifted to defining the characteristics of this science. This led to the question of what such a science entails. The philosophy of science forms the foundation of social science research, and this should be very clear to all the students of social sciences, particularly psychology. Social research is shaped by assumptions which are based on a philosophical perspective of science. That is what I mean to say here. In other words, philosophical thoughts have influenced the progress of social science. Philosophy of science, we will see, has originated from Greek philosophers' attempts to understand the existence of world through metaphysics and theology. Philosophy of science has been considered a distinct philosophy since the 20th century and it is constituted of different components like empiricism, rationalism, and positivism. We are going to examine each of these in detail. The philosophy of science is a meta-theory that includes assumptions about ontology, that is, the study of social reality. Number 2, epistemology, which is how do we gain knowledge of social reality. Number 3, etymology, that is, the study of the causes of social reality. And finally, methodology, the methods we use to address questions related to social reality. Now let us examine what is the meaning of science and social sciences, the question we had already asked in the beginning of this lecture. Throughout history, notable figures like Galileo and Kant have argued against the scientific nature of psychology. Why? Because it focuses on subjective experiences. Many scientists in the natural field still hold this belief, and there are also psychologists who would agree with them that since psychology focuses on personal subjective experiences, it cannot be called a scientific enterprise. To address the question of whether psychology can be considered a science, it is necessary to begin by identifying a clear definition of what constitutes science. So, in the next section, we will see what is science and what are the features of science. Now, as all of us are aware, science emerged as a means of investigating nature directly rather than relying solely on the teachings of religion, past authorities, superstitions, or abstract thinking. So, since the beginning of science, empirical observations has served as its primary source of authority. In order for observations to be valuable, they need to be organized or categorized, and the similarities or differences to other observations must be understood. So what is meant by empirical observation? Let's see this. Empirical observation is anything that is relying on your sensory experiences. So when you collect data based on your sensory experiences, like if you are hearing, seeing and touching, and then collecting information from the social world around you, it is known as empirical research. And it is not random observation, but if it has to be relevant, we must understand that this needs to be categorized or organized and compared with other similar observations so that we can identify if there are any similarities or differences among them. Let us now examine some of the major features of science. Rationalism and empiricism are the most remarkable feature of science. Science is commonly described as having two main components, empirical observation and theory. The earliest attempts by humans to comprehend their world demonstrate the presence of these two fundamental elements of science. Science is a powerful tool because it combines two ancient methods of attaining knowledge, which is rationalism and empiricism. Now, what is rationalism? Rationalism is a belief in that knowledge can only be acquired through mental operations. For example, rationalists argue that applying logic diligently can prove the truth or falsehood of specific statement. On the other hand, the empiricist claims that all knowledge stems from sensory observation. True knowledge can only be derived or validated through sensory experience. Science has merged the two positions, resulting in a rapid accumulation of knowledge ever since. Extensive research has shown that rationalism and empiricism, however, have limited utility by themselves. A rational approach to science, for example, prevents a collection of disconnected empirical facts by focusing on coherence and connection. So there may be many more facts which would be related to the problem, the research problem at hand, but we just ignore them and we are only focusing on or trying to attain coherence and connection in our data. Secondly, the formulation of theories is very important for scientists to make sense of their observations. A scientific theory has two primary purposes to serve. A. it organizes empirical observations, and B, it provides guidance for future observations. The primary purpose of a scientific theory is to produce testable statements. Put simply, a theory proposes ideas that are then put to the test through experimentation. So, experimentation is the method through which we can test theories. When a theory's propositions are confirmed through experimentation, it gains strength. Conversely, if the propositions are not confirmed, the theory loses strength. If the theory produces a significant number of incorrect propositions, it should be either revised or discarded. So, we want to tell here that scientific theory must be capable of being tested. In order to be considered valid, hypothesis is testable statement which is about the relationship among variables, and it can be put to test to find out whether it supports the theory, or it is not conforming to the theoretical propositions. So, in order to be considered valid, this hypothesis must be capable of being empirically validated or invalidated. In the realm of science, the significance of directly observing nature cannot be understated. However, it is crucial to note that these observations are frequently influenced by underlying theories. So, there are many features of science that we want to examine, and in the course of examining the features of science, we see that the second important remarkable feature is about lawful relationship. Science seeks to uncover lawful relationships. A scientific law is a relationship that is consistently observed between different classes of empirical events. For an example, when X occurs, Y too usually occurs. So, this kind of lawful relationship is what science wants to establish. By emphasizing the importance of following lawfulness, science demonstrates its focus on general principles rather than specific cases. In the domain of science, the focus lies not on individual or personal occurrences, but rather on universal principles that can be openly observed and verified. Knowledge in science is not restricted to qualified authorities, but it is accessible to all. Scientific laws can be broadly categorized into two classes. Number one is correlational laws. Correlational laws focus on explaining how classes of events vary together in a systematic manner. For example, there is a positive correlation between scores on intelligence test and scores on creativity test. So, this can be an example of a correlational law. It is possible to predict a person's score on a creativity test based on their score on an intelligence test and vice versa. Based on the available information, it is possible to make predictions when we use correlational laws. Second category of laws are causal laws. Causal laws are a more potent class of laws that outline the causal relationship between events. For instance, if we had a thorough understanding of the factors that contribute to a disease, we would be able to make accurate predictions and effectively manage the disease. By proactively addressing the root cause of disease, we can also effectively prevent its occurrence in future. Therefore, correlational laws enable the ability to make predictions, while causal laws provide the ability to make predictions and exert control. Due to this rationale, causal laws hold more influence than correlational laws and are therefore typically regarded as more preferable. Understanding the causes of natural phenomena is a fundamental objective of scientific inquiry. So, understanding the cause of natural events is a highly complex process that usually requires extensive experimental research. It should not be assumed, for example, that contiguity leads to causation. Example, we cannot say that when rain occurs after a rain dance, it cannot be automatically concluded that the act of dancing directly caused the rain. It should also be noted that events rarely, if ever, have a single cause. Instead, they are typically influenced by multiple factors. Questions like what caused the Second World War and what causes schizophrenia remain unanswered because there are multiple factors which may be leading to it. Even simple questions like why Rahul quit his job or why X decided to marry Y are complex. Throughout the history of philosophy and science, the concept of causation has posed numerous challenges. Another feature of science is the assumption of determinism. Science is driven by the pursuit of discovering lawful relationship. We have already seen this in the last section. It operates under the assumption that what is being investigated follows a set of principles. For example, the chemist operates under the assumption that chemical reactions follow consistent laws. Similarly, the physicist operates under the assumption that the physical world also adheres to consistent laws. Understanding this subject matter through causal laws is referred to as determinism. So, determinism is the philosophical belief that all events are predetermined by certain conditions. Determinists believe that events are caused by a finite case set of causes and can be accurately predicted if these causes are known. Knowing all causes of an occurrence is not necessary. Determinists presume their existence and predict more accurately as more causes are identified. While most agree that weather is influenced by variables like sunspots, high altitude, jet streams, and barometric pressure, weather forecasts are always probabilistic due to constant changes and unknown factors. The assumption behind weather prediction is determinism, and we know that all sciences assume determinism. Now, this view presented was a traditional view of science, the classic view of natural science, and it can be traced to the emergence of science. So, the initial phase of science was when they believed in empirical observation, they believed in all the features we have discussed in the previous section. Revisions were made to this traditional view of science by some of the eminent, notable philosophers of science. We know that science so far typically includes empirical observation, theory formulation, testing, revision, prediction, control, the search for lawful relationship, and the assumption of determinism. So these are the features of the traditional view of science. However, there were several notable philosophers of science who disagree with certain aspects of the conventional perspective of science. Two notable figures are Karl Popper and Thomas Kuhn. Karl Popper challenged the conventional depiction of science in two major ways. Number one, he argued against the notion that scientific work commences with empirical observation. According to Popper, the conventional approach to science means scientists observing phenomena and later attempting to provide explanation. But in his own classroom, he tried to instruct his students to carry out observation, and in the course of giving the instruction, he just told them to take a piece of paper and note down their observation. The question that students asked was, what should we observe? So Popper pointed out a problem in this viewpoint from his experience in his own classroom. He says that when asked to observe a phenomena without any specific instruction, people generally ask what has to be observed. Thus, all observation is selective. It requires a specific object, task, interest, perspective, and problem. So, according to Popper, scientific activity begins with a problem, not with the observation. So the first step is problem, which guides the observations made by the scientists. The next step after the observation is to offer solutions, that is conjectures, and then investigate faults, that is refutations. The scientific method, according to Popper, involves 3 stages: problems, theories, and criticism. According to Popper, the concept of falsifiability distinguishes scientific theories from non-scientific ones. For a theory to be considered scientific, it must be able to be tested and conceivably proven false. In contrast to the popular belief, observations that agree with a theory do not indicate its strength. Popper extensively criticized Freud and Adler's theories for this reason. Any behavior can be supported by either of these theories. So these theories are vague, and the vagueness of these theories allows for their proof regardless of whatever happens. Einstein, which accurately predicts outcomes if correct. So Einstein's theory, unlike Freud, Adler, and astrological forecast, was scientific and refutable.